Am I audible to you all? Yes. Okay. So there are very few participants today, only 4, and we will take the remaining part, and I will explain you and I will share. Yesterday I could not share it, so first I share it with you. R3. Just a moment. R3. Linear regression. It was the day 6 and the day 7 I had to share. Day 7. Loading the files. So okay, I have shared the files also, and we continue. I will explain you. You have to do something with yourself and that is script, and because we have limited time, so yesterday what we have done, I will continue from there, and I will tell you later on what have to be done, what we can do with improving this model accuracy. Okay, so I just run it. This we had data yesterday. All are integer and the double we have.
Sir, screen not shared, sir.
Okay, okay. Yes. Now it is visible to you. Okay. And
Yes, sir.
then we have divided this data into part. I am telling and taking the final model, this one. And I will show you the summary. So this we have done yesterday. Okay. Later on, we have taken this, and I will have shown you this output of head, and we have generated this GG plot yesterday. Got it? Up to here we have completed. Now what we are going to do, this I have done, but it is not complete. I will explain later on this. First we see as per that model what we have produced. We will take some cutoff value here. So what I am going to do, uh, I am taking one table, uh, data frame I am making for cutoff 0, TP 0, FP 0, FN 0, and TN 0. These are the variables I am taking. All values are 0. And if I show you this, so you will see this I am getting. Okay, only the one variable. Now I am taking the sequence from 1 to 100. Okay, in the cutoffs, and these are the 100 sequence I am getting here. And I'm using one for loop, cutoff in cutoffs, and predicted s dot numeric and this all, and I run it. And now I'll show you this head, so you will get this here. Now this first observation I am removing from here, and if I view, so you could get this the TP. If we take the cutoff 0, if we get the cutoff point 0.01, we get this, and this way we are getting the 100 cutoff points. Got it? Does that make sense to everyone? Okay. Now I am taking few points. I am making a P, sensitivity, case, and accuracy, and N. Sensitivity, specificity, distance, and case, accuracy. These points I am taking. So I will run it. So then I will show you that cutoff again. So if you see the cutoff data, we are getting these all points. Okay. And so
Sir, what is that KS?
case I explained yesterday. Uh, Again, I explain you that thing. Kolmogorov, that is Kolmogorov Smirnov statistics. Okay, this is
Okay,
like
sir.
this
Okay,
the
sir.
formula for that.
Okay.
So the select the cutoff where k is higher. Okay,
Okay, sir.
so we see the k is higher. So how we get it? Um, we see first the maximum. We see that value first, which one is maximum. So this is my maximum value, and then I'm searching it. I copy this and I paste here. What happened? Okay, it is not working. It is 0.82. So if you search here, we have not a big number here. So 82 case. 82 is not there in the case. Why it is giving me? 822. It is not there.
Sir, it was there.
Hmm?
Yes, sir, it was there.
No.
Sir, it was there. I saw when you were scrolling down now, it was there in KS.
Okay, we'll see. This one. Okay.
Yeah, yeah.
Then why it is not showing me that? So what is this 0.11? Got it? At the 0.11, if we take the cutoff, then we get the accuracy 0.91 and the sensitivity 0.90, specificity 0.91, both are good. Okay, getting everything. So we take cutoff 0.11.
Sir, so maximum we have to take.
Maximum. Okay, sorry. So I am taking 0.12. Okay, 0.11 I could also take 0.11. That is, we have got the 0.1111. Okay, so because it is 0.1111 many times, so I could take the 0.12 or 0.11, whatever you like. So what I will do, test I have to run for test first. I will take for the test data. Okay, and do it for the test and predict this score and getting some. If I show you the head, I will get the probability. This probability I am getting, and I will take this as a cutoff in the test data. Okay, and then I do it as a factor. Okay, and then I actual revenue grid as a also factor in the test data, and then I'm making a confusion matrix. It is the I will show you this first. So we are getting this confusion matrix 0.908, and we see the sensitivity and the specificity for the test data. Okay, in the positive class it is 0, we are getting the 1. So I just check it. 0.85. So it is the sensitivity. Your sensitivity, we know that sensitive is the 00 and 286. So we check it. We check it with the test data. 2456 plus 268 divided by 3016. It is 0.90. So it is not a correct specificity. Sorry, sensitivity is not correct. It is showing the specificity. Okay. And the previous one, I am getting this sensitivity. Okay, okay, no problem. Sensitivity is 0.9086.
So that confusion matrix function, it will be there in which package, sir?
Caret.
Which package?
Caret.
Yes. Okay.
So first one is correct. Positive class we are taking 0. That is correct. Okay. So first one is correct.
What is positive class equal to 0?
That is the, we are 0. There are two things. First, we are writing here in the confusion matrix. You see, we are writing the predictive first, and later on we are writing the revenue grid. So positive value we are taking 0 as a, okay, yeah, for this algorithm. And if I change this, then I have to mention positive equal to 1. Got it? Sequence, if I change the sequence. Okay, so you,
Okay,
whenever you take this, you just check it. Okay, we could easily check it. This 00 and this, you add on this and divide by total and see the sensitivity. It is equal, then okay. Okay, so it is giving us good sensitivity in the specificity basically, and the accuracy is also good for the test data. Got it? Are you agree with this?
Sir,
yes, sir.
Yes.
Sir, in like 0, you we have here sensitivity 0.9086, and in other case, like positive case 1, it was showing from 0.8. So
And that is
sir,
the reverse it is giving
okay.
us,
So why it is like that?
because this sequence always do that thing. If you write this first and this later.
Okay.
Okay.
And yeah, this was the case for 0, right?
If I write in the opposite way, you see,
Yeah.
I will show you that also. Everything should be in the factor form. Okay.
Okay.
I have converted in factor. You see, test prediction also, which is in the 0 and 1 after cutoff. Okay, this prediction I will show you in RG test. 0 and 1. Got it?
Yeah.
And this is the actual what we have got, the revenue grid. That is the actual. We also convert it in factor. Okay.
Yes.
Then we could find out in the confusion matrix, and that is compulsory. The both should be in the factor.
Okay.
Just a moment. And I will show you that. I just remove it. Okay.
Yeah.
And if I run this, you see what is the difference between both. Revenue grid. I have run here the revenue grid and that test 2, 4, 5, 6, 4, 45, 247, 268. Accuracy is same. The sensitivity and the specificity you check. Got it?
Yeah.
It is not correct.
Yeah,
If
both
you
are
write
same.
here,
Yeah.
if you write here, where is that? Mhm. What is that? Where I have written this? Here. And in inverted, huh?
Yeah.
Right one always inverted. No, it is also giving me wrong. It is giving me wrong.
Okay.
It is positive one. It is also because the sequence, if we change, because they have changed the algorithm in the confusion matrix.
Okay. So
Okay.
sequence should be same always.
Yes.
Yeah.
First, you have to write the predicted one,
Okay.
and later on you have to write that our this predicted first, and this reference later on.
Okay, sir.
Okay.
Yeah.
Because they have changed the algorithm basically. Because if you see in the that I will show you. You see here it is the actual then predicted. Got it?
Yeah. Yes, sir.
But what we are doing here, first we are writing down the predicted first, and then actual. So they have changed the that algorithm before some time, and they have not changed here.
Okay. Okay.
There's the reason. So we have to cross check it whenever you take it.
Okay, sir.
Okay, so sensitivity and specificity we could check. We know the formula.
Yeah.
We could check it. So it would be confirmed. Okay.
Okay,
Then
sir.
the accuracy we could check. Okay.
Yeah.
If I check the this what we say, these are the reference. So how we check it, I tell you, I have not checked the properly. Now I check it properly. Just a moment. I have get the actual and predicted. Okay. The actual, write the reference and predicted 0 1 0 2 4 5 6 and 45 2 4 7 and 268. Get the total 13 9 6 and 11 12 13 till 13. So 2 4 5 6 we have done that. I do it. So this we have 2 4 5 6 and 2 4 7. First I see the I again run it. I will run it later on. First I see the accuracy. So 2 4 5 6 sorry, plus 286 divided by total. This is the accuracy. So total we have.
Sir, it is 268.
286 or 268?
268.
No, it is in this data, not in this. We are going to see here. I will run that again. Where is that? This one. Okay. Here you see what you are getting here. 268. Okay. 267 divided by 3016. Okay, correct.
Yeah.
Accuracy is correct. 9032. Now we see the sensitivity. Okay.
Okay.
So sensitivity is true positive. True positive we have 268. 11. Okay.
Yeah.
268 divided by sum of 45 plus 268. Correct. Okay. This total, actual total.
Okay.
That is P. And we have a transform form of that, which I explained you in the PPT. It was the transference. Okay. Transpose of that. So it is giving me in that way 0.85. So it is giving me, it is not a sensitivity. It is a specificity. It is showing me. Correct.
Yeah.
But I have measured the what? Sensitivity. Got it?
Yes, sir.
So what I do, I just is not giving me this correct. I will write here. Where here? Now I see. What I get? Sensitivity 0.85. Now you see the sensitivity.
Yes, sir.
Accuracy is same. Now I see the specificity. Okay. These figures are same.
Yeah.
Okay. So specificity is what? True negative over negative. This is the true negative and over this total. Correct?
Yeah.
So 2456 divided by 2456 plus 247. Correct?
Yeah.
9086. What is the specificity? 9086. Okay.
Yes, sir.
So this is the positive clause we had to put first. Got it?
Yes. Yes, sir.
So it confusion matrix is always creates some confusion.
Yeah.
So we have to cross check it always. Okay.
Yes, sir.
So we have to use sometime positive clause equal to 1 because we have taken 1 is a positive. Okay.
Yeah. Sir,
So
one question. So
yes.
like in case of specificity, true negative by negative, right?
By negative.
So negative total will be 2456 plus 45 or
Yes, yes. These two.
so
This
this
is the
two are
reference means actual.
okay.
And in our PPT, we have given the reference
Yeah,
here
yeah.
and the prediction here.
Yes,
That's
sir.
the thing. Okay.
Yes, sir.
So here we will get the total here.
Okay.
It is the T. This one 45 plus 268 is the P. And 2456 and the 247 is the N. Got it?
Okay, sir.
Because we have the transform this, na? And here it is the
Yeah.
transpose form. Okay.
Okay, sir. Yeah. Thank you, sir.
Now the model is giving us very good. Okay. So this is the best way to select this, and you will see here also we have the ROCR curve. This is the ROCR library, and here we are using the caret for the confusion matrix. Okay. And I have shared this script to you, and I will show you this. First we create a curve, and then we see that also. I will show you that plot where we use it. You see here, this is a plot, AIC area under curve AUC and the ROCR curve. It is the false positive rate. This is the true positive rate. So you see here we are getting, if we go down here, so 0.1. So there is a very little decrease in this true positive rate. Okay, and the false positive decreasing too much. If I show you, you see, you see here height and breadth. Okay, and then if I go too much down, then I am getting only very little change in the false positive rate. Got it? So what I will select between 0.1 and 0.2. Understand? So there is a low decrease in height and the high decrease in width. Got it or not? This is another way. Through KS we have got the perfect one. Okay.
So this is another way of selecting the cutoff.
Cutoff, yes, correct. Okay, but it is we get the range here. You won't get the exact value what we were getting in the case. Okay. Understand? So this we also consider sometimes. Okay, and AUC we could see, show you this thing, you run it and you could see this curve over there. It is the area under curve is 9.94. Okay, the total area is 1. That is 0.94. It is a good. And this we have taken in that way, the 0.11 again. Okay, so I measured it. Yes.
Sir, I have a doubt. The graph which you are showing, ROC curve, so where exactly it indicates the cutoff point? I did not get, because x and y axis are probabilities, right? It is between 0 to 1.
Yes.
So where it is exactly showing 0.11?
Here you see here. This we have given, na? These are the cutoff points, cutoff probability I am giving here. This is the probability of true positive rate and the false positive rate. It is the rate.
Okay.
This is the probability what I am telling.
Okay.
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 Wherever the dy dx is low, then it would be better for you.
Mhm. But where it is exactly showing 0.11 cutoff?
No, it will not show you the exactly. It will not show you the exactly. It will just give you an idea.
Or maybe the lower point is there.
You see
That the
what?
single point.
Okay, I will tell you the thing. Just a moment. If we go down, it is decreasing our true positive rate or not?
Yes.
And if I am going here, so it is decreasing our false positive rate.
Yes.
So we are decreasing the true positive less than this. This height is less than this breadth. You know that here? Are you getting it?
Yeah. Yes.
So this
Yes.
is better. This is better. True positive rate we are losing very low, with compared to false positive. Got it?
Hmm.
So you could switch from 0.1 to 0.2. So it should be somewhere between 0.1 and 0.2. But here in this case, if you see, we are going down, okay? And we are shifting to false positive rate is very small with compared
Okay.
to true positive. So it is not a good thing. You are
Right.
losing your true positive rate too high
Hmm.
with compared to false positive.
Right.
So
Right.
it is not good. No, nothing is not good here, you see. Okay, no one is good. Okay.
Right. Right.
So you will get you can select that point from cutoff point from 0.1 to 0.2.
Hmm.
Now you will put different point, 0.11, 0.12, 0.13 in this way. Then you see. So it will take very long time.
Hmm.
You don't have exact value here. You will not get the exact value.
Okay.
Got it?
Yes.
It just give an idea, rough idea, where your cutoff
Okay.
will lie. Okay?
Mm-hmm.
That is the thing. So
Okay.
case value is the perfect one. So I have developed that technique because we don't have any library for making such table like this. Got it? Okay.
Yes, sir.
So I have created that function in the for loop I have applied and I have got this. So this technique you could use and you could find out this value. You will get the accuracy also for the, it is for the training data. Okay. And we select that and that cutoff we will use in the test also. Got it?
Okay. Okay.
Here you are getting the sensitivity space. This is deviance also, but we will not consider it. I have kept it. Okay. And this is the true positive, false positive. You see here we get that at the 0.82. If I show you where it was, 0.82 is this one. You see we are getting that 0.1, but we have taken the 0.12. Okay.
Mm-hmm.
We have taken the 0.12 na? Or 0.11 what we have taken. I don't know.
0.11 only we have taken.
But we have taken we are taking that confusion matrix for test data. Understand?
Mm-hmm.
This is for the training data.
Okay.
Got it?
Yes.
If you make the confusion matrix for the training data, you will get the exact this figure. Got it?
Okay.
Exact
Okay.
this figure you will get. If you use the, instead of test, you use the training data there in the confusion matrix. Okay?
Okay.
Is there any doubt?
Sir?
Yes.
So yesterday, as we discussed, like if probability is equals to, we are getting 0.1, and for p equals to 1, like data was imbalanced, so we need to balance.
Yes, I
You
will
said?
tell you that. I will
Okay.
tell you that.
So sir,
Because
till now we were finding the cutoff.
we have found the cutoff na here.
Okay, okay.
But at that moment, what I say that if we have imbalanced data, what I feel,
Yeah.
if you have one category value is very less means it is less than 5%. Understand?
Mm-hmm.
Then we feel it is an imbalanced data.
Okay.
But here in this case, that is not, but I explained that also. I have merged that thing, but I have not run it. I will show you that. Just a moment. You see here, I have add on this thing. Okay, but I have not completed.
Okay.
There are three methods. I will share this script also for the balancing. So I am using the both. Okay, both I am taking the whole data number 7035. You see here in the training data.
Mm-hmm.
So I will do for the training data only.
Okay.
And we are making the model through the training data. Na?
Yes, sir.
So we will change that thing in the training data. Test data, we don't have the test data now, suppose.
Mm-hmm.
We'll get later for the testing.
Yes, sir.
So what I am this is the rows library. We have to use this package.
Okay.
And the function is o1.sample revenue grid tilde dot, that is the target, tilde dot data rg underscore trend method both. So we have three methods. Okay.
Okay.
So I will give you that script. You could better understand that. We just have to change here. Okay. And this is the probability. I want 50% approximate, 0 and 1. Understand?
Yeah.
Or it is a bootstrap method, or it is a random basically. It will do the randomly.
Yes,
This
sir.
task. So we set some seed here there. So I have taken the seed 2 to 2. You could take any number for the seed. Okay.
Okay, sir.
Either 1, 2, whatever you want. 2 digit, 3 digit, 4 digit, 5 digit number you could choose. by yourself. And the N, I am taking the total data observations, 7035. And dollar, after dollar, you have to write the data only. That is specific. Okay.
Okay, sir.
So I will show you this. If I run this, okay, I have to run this first. Before that, I will do one thing. I will remove the score. Score I will not include. Na? Understand? Score column we have generated later on.
Yeah.
You know, when we have got the prediction. So I remove it again from the RG train. Okay. So RG train, you see we have the 41. And we see whether it is there or not. Score is there.
Yeah.
So I want to remove this one. So I am getting 40 variables. And then I run this. So this is the both. Yeah? Here I will show you the table of this revenue grid. So you see the table. Got it?
Yes, sir.
Now, what you have to do, you have to again train the model from starting.
Okay.
Got it?
Yes, sir.
And then do the same process again. Understand? So I have not done the whole thing. I have done little bit. You try yourself and get it and see the difference. One more thing I have not intentionally, I have skipped that thing during processing. So nobody has interrupted me about that.
Test data pre-processing.
Yes. So we have not seen the skewness. Understand? Of the numeric variables. Have we judged it? We are not done with any variable. Okay? Got it? So I have here, you see, histogram we see for this. So this the skewed is, I see the skewness of this. So it is the 3.61, highly skewed. Got it? So I have intentionally skipped these steps. So you have to work whatever the numerical data you accept binary. Okay, don't take the binary or the categorical, just for the numeric one. First you check it. We have worked for the categorical data later on. You see, we have worked for the categorical data. Okay, this all work we have done for the categorical data. Dummy variables we have created. Got it? But we have not worked for the numeric data. Understand? So that's you could do there, and you could see the accuracy will improve. Okay.
Sir, for logistic regression, whatever numerical variables are there, those need to follow normality assumptions, because in linear regression, we check that first of all.
Yes. So why I am telling that, na? We have to see the skewness and we have to give the treatment to them.
But logistic regression does require to fulfill those assumptions?
Yes. Both are the same thing. Just we are getting here the probability instead of the Y value.
Okay.
What output we are getting through the GLM? GLM, we are getting the output in the form of probability. Then we are giving some cutoff and converting them in 0 and 1.
Okay.
Instead of Y value, we are just getting the probability. Here on the right side, in the domain side, we have the process are the same as per the linear.
Okay.
Everything is as per the linear regression. Okay.
Fine, sir.
So that we have to work for that. I have intentionally, I don't mention that thing. I want to see the participants interrupt me or not. Okay, so there are many. It means that we have to first make a outline what we have to do with the data, the generic outline. Okay, and as per that we have to start the work. Correct. Some process we could not miss. So this is all about the logistic regression. I have shared the data and everything. Okay. Today I have shared it in the folder, the yesterday folder, and you try to do it. And tomorrow we see the new chapter, which is segmentation and clustering. I think that. Okay. So you work with this, and still we are getting the good accuracy. Not bad. 90% it's too high. Okay, but it may be overfitting. Got it? It may be overfitting.
Sir, I have another doubt. In between this script, you have used some lift word. What is that exactly? Because initial part today I missed. So if you would have explained that, I would have missed it.
The lift I have not explained anywhere. I have taken that, but that is also a measure like the sensitivity, specificity like that lift.
Okay.
So we don't consider that. There are so many measurement. So we have not considered it. Na? You see, I have written there, but I have uncommented, commented. So it is
Sir,
not being run. I will show you here.
it was used, I guess.
No,
Sir.
we have not used this lift. This lift, you see, I have not used it. I have, you see here, it is. We get through this. TP over P, TP plus FT, P plus N. This is the formula for lift.
Okay.
And this is all thing is there in the PPT. In the detailed way. You will see this. Custom measure, logics. This is the custom measure we are getting. Or that is not usable lift. Okay. Nobody used that. We just see the sensitivity, specificity, K is important, accuracy is important. Okay.
And along with AIC, there is also term called as BIC.
Yes, yes.
So is that also used, or that is not important?
That is not important. That is not important here. Here it is, that is not important. That is important in the decision tree in the random forest somewhere. Okay.
Okay.
Here we just see the sensitivity, specificity, accuracy only. Okay.
Yes, sir.
Today I wind up here only. Okay. And tomorrow we see the next chapter, segmentation, clustering. You work with this. I have given you the whole idea how to perform this logistic regression. Okay.
And sir, are we covering a multi-dimensional technique as well, which
No,
is
no,
used for
multinomial.
segmentation?
Multinomial what?
No, multi-dimensional.
Segmentation. Yes,
No,
yes.
not multinomial. Multi-dim.
Dimensional in the
So in
segment.
segmentation,
Yes, yes, yes. Multi-dimensional in segmentation. We'll cover it. Have you attended that segmentation and clustering?
No. It's there in this workshop, right?
Okay, okay. So there is a multi-dimensional. Okay.
Okay.
The one dimensional we have done here, na, that proportion target method we have done yesterday. Yesterday you was not there.
Yeah, I
Yesterday
was
we have done that proportion. You know that we have accumulated the few categories in one.
that is target encoding.
Target encoding. That was a one single dimensional, na, with that our
Okay.
target variable.
Okay.
And here we see the multidimensional. We see for the numeric variable. All variables should be numeric.
Right.
Or scaling is very important over there. Right?
Right.
We see tomorrow these all things.
Okay. Okay.
Okay.
And sir, last doubt, how we carry out ordinal logistic regression? Uh, you have shown most of the steps related to logistic regression, but in this scenario, how uh, ordinal will be processed?
There is a no much difference. The formation would be same. Formation would be same. Ordinal, there is a, if you search on the net, you will get about it. Okay. Ordinal, we instead of ordinal logistic regression, we think better is the decision tree for that ordinal purpose.
Okay. Okay.
Okay, we generally do for the numeric one. This
Right. Right.
decision tree is better for that.
Right. Right.
Okay.
So ordinal acts like a prioritization only. So decision tree will help us in prioritizing the things.
Yes, yes.
Yeah.
You could do also with this, but you have to search on the net. The little bit maybe some algorithm maybe change.
Mhm.
Okay, you could do it with this logistic also.
Right. But entire the criteria of selection like accuracy and specificity, sensitivity will remain same in.
Remain same because we have the target variable is the binary, na?
Yeah.
The
Yeah. Yeah.
logistic.
Right. Right.
So other thing will remain same.
Okay. Okay. Fine. Thank you, sir.
Okay. Thanks everyone. Meet tomorrow.
Yes, sir. Thank you, sir.
Okay. Thank you.